Hello, welcome to the open source educational resource Microprocessor 8085 instruction set. Link for this OER is shown here. You will get different uh, resource links from this website. Learning objectives. Now they are define machine language, define assembly language and need of assembler, define categories of 8085 instructions, identify opcode and operand of instruction, identify registers used in 8085 instructions, identify valid pairs of 8085 registers used in instructions. Evaluation strategy. Different types of questions may be asked and marking scheme is also shown. These questions will be placed on the URL shown in slide 2. Now let us start with the introduction of assembly language and machine language. A microprocessor or microcontroller or DSP is a hardware which executes instructions of the program. The program is written by user and it is stored in the memory. Now instructions should be in a language known to the microprocessor. Microprocessor understands the language of zeros and ones only. This language is called machine language. Microprocessor cannot understand a program written in assembly language using some editor. So then an assembler is needed to convert assembly language program to machine language program, which then can be executed by microprocessor. Now what is instruction? It's a group of binary bits with special meaning and designed as per architecture of microprocessor, microcontroller or DSP to perform a specific function or operation. For example, 8085 has 246 instructions. Now what is the format of instruction? So assembly language instruction consists of opcode and operand. What is opcode? It is the operational code or command by which microprocessor decides which operation should be done or performed. Operand is either data or an address on which operation is to be performed. The length of the data or an address is of either 8 or 16-bit for 8085 microprocessor. Two examples are shown: move A, B and move MVI A, 32X. These are two instructions of 8085. So in the first instruction, move A, B, move is the opcode, A and B are the operands. So here content of B register will be transferred to A register. In the second example, in A register, immediately 32 hex content will be loaded on successful execution of this instruction. Now according to number of bytes occupied in memory, there are three categories. There are three types of 8085 instructions: 1 byte instruction, 2 byte instruction and 3 byte instruction. In 1 byte instruction, both opcode and operand are used or shown using only 1 byte. In 2 byte instruction, first byte specifies the opcode, while the second byte specifies operand as either data or an address of 8-bit. The next one is 3 byte instruction. First byte specifies the opcode and other 2 bytes specifies operand as either data or an address of 16 bit. So here you will see that always the first byte is for opcode and rest of the bytes are for operand in case of 2 byte and 3 byte instructions. While in 1 byte instruction, both opcode and operand are in the same byte. Now, what is the register structure of 8085 and how 8085 access memory? So, here Microprocessor register structure is shown where 8-bit registers are shown: A, F, B, C, D, E, H, L. Program counter is a 16-bit register. State pointer is a 16-bit registers. All these registers are used in different 8085 instructions that we will study in different video modules. Now, the program of the user resides in memory where different instructions are resides. So, 8085 can address 16-bit memory. So, range of the memory is from 0000x to FFFFX, and some portion of that memory is shown where each memory can store 8-bit data. So, in program we need instructions as well as data. So, 8085 has program memory and data memory also, but both are program and data are shown in the same memory range. Instruction format 1 byte. So here you can see that data transfer instruction has opcode and operand. Arithmetic instructions has opcode and operand. Logical instructions has opcode and no operand is shown. It is a 1 byte instruction. Meaning of RD and RS is shown. Meaning of R is shown, and this may be learned later on in different types of instructions. Instruction format 2 byte. So here 2 bytes are occupied in memory. So first byte is opcode, second byte is operand. So these are the tasks, data transfer task, and here arithmetic task is there. And here the meaning of RD, RS, port, etc. is shown below. Instruction format 3 bytes. So here 3 byte instruction may be data transfers, and here opcode and operands are shown, and meaning of RP, RD, etc. is shown. When we learn different instructions of different classification, it will be more clear. Classification of instruction set is data transfer instructions, arithmetic instructions, logical instructions, branching instructions, control instructions. Thank you all.